Our next topic presentation is titled Traffic Impact Analysis in a Changing World with Beth Ostrowski from KCI Technologies. Beth has worked on a broad range of transportation projects, including design, signal timing optimization, traffic impact studies, and ITS, and for both public and private sector clients. And this is really interesting to me. In each of the last, I mean, that was interesting already, but it's very nice. Everything's interesting. But of a special interest for scale is that in your bio saying that you and your team have completed in each of the last 2 years, over 100 traffic impact studies in and around Metro Nashville. So that's a huge amount of projects. Having been a consultant in a past life, kudos on that to begin with. But secondly, that's an amazing story about what must be going on in Nashville in terms of the economy and the development environment. So we really look forward to your presentation. With that, I'm going to hand it over to you.
Awesome, thank you. So it looks like you can see the proper screen. Is that fair?
That is correct.
Okay. And I think you stole my thunder for my intro slide. Yeah, we have completed over 100 studies, my team, in 2018 and 2019. And conveniently, I went back and counted just a week or two ago. And I think we're at like 78 to 80 for this year so far. So we are on track to do it again. So I'm going to talk about traffic impact analysis in changing world, and this presentation is kind of split into two parts. You'll see as I get to the second half, I'll get more into the Bistro, but to start talking about kind of how we've gotten where we are going with a lot of our studies, and just what we're proposing to clients, municipalities mostly, moving forward. So as we discussed kind of in Nashville, the last decade has proven to be one of great economic prosperity, cultivating a pro-development environment in many urban areas. Nashville is definitely one of them. With the rapid growth, investment in our transportation infrastructure just is lagging behind the pace of development. And in that same time, innovations in technology have continued to impact driver behavior and added complexity to how our road network is utilized. So it's vitally important that we as traffic engineers understand the impacts of these changes to our processes for analyzing proposed developments. So for the first half of my presentation today, I'm going to discuss how these changes impact traffic impact analysis, specifically background growth, trip generation, trip distribution, and determination of mitigation measures. I'll highlight challenges that my team has encountered and address changes to our process that we've implemented to overcome these challenges. So jumping first into background growth, specifically background development, Nashville and the surrounding counties have experienced record growth for much of the last decade. This has led to an explosion in development in the pipeline, under construction, and newly opened. For many traffic impact analyses, us as engineers were asked to look at like 1 to 2, maybe 3 background developments. And in high growth areas, it's just really not enough. We can't just look at the blocks adjacent to what we're studying. We need to be considering the overall roadway network, particularly for developments that are maybe close to an interchange or near an intersection of 2 major arterials. When we look at trip generation, we see in recent years an increase in experiential retail. This might be one example in Nashville is there's a makeup store that has all these like Instagram pop-up locations. So people go just to take Instagram photos. So it's a hot spot more than you would expect a regular makeup store to be. Excuse me. And there's an ever expanding variety of restaurants and entertainment options these changes have impacted and affected our ability to produce meaningful trip generation results. The variety of land uses is really expanding faster than data can be collected and analyzed. Also, when we're considering the impact of trip generation, there's other trends. For example, the increase in rideshare and the increase in valet. Here in Nashville, we're starting to see valet for office users being proposed. There's increase in, COVID impacts, grocery delivery, daily services deliveries, Uber Eats, and, things of that nature. And we need to also be preparing for connected and autonomous vehicles. So many of these trends that I've discussed here impact distribution. So when we're doing traffic analysis, we need to consider where valet, rideshare, and daily service deliveries will drop off and pick up. For distribution, oftentimes we include a percentage of trips going to a primary non-parking access point, such as a portico, and as an origin destination point. Further, the use of these mapping applications has changed the way people decide their preferred route. So checking, what we do is we check Google Maps, Waze, and other popular apps to validate our distribution. We also have used Streetlight, which I'll talk about a little bit later, but even when we have Streetlight, we still back check on the free mapping applications that drivers use, because sometimes the routes that are being recommended to people are surprising, as an engineer. Okay, so once all these elements are considered, we face a different kind of challenge. All of these images you're looking at here are Nashville, by the way. Particularly in Nashville and other fast-growing cities, we have to analyze conditions in overcapacity, geometrically constrained networks. And, we find basic turning movement counts are counting capacity, not volume. The saturation flow rate is likely not a default 1,900 vehicles per hour per lane. And private development clients specifically don't expect to pay for the complicated analysis required to adjust these factors, particularly because they own one corner on a network that requires like massive improvements, bottlenecks everywhere. And if the right-of-way is not there, they can't be making those improvements, even if we did have all of the data. So we find in these situations that level of service is no longer really a valuable metric. It's become increasingly an issue in many urban areas. I know Nashville's not alone in this. Instead, we typically will use V over C ratio or 95th percentile queue length to provide a clearer picture of how the road network is functioning. Additionally, something we're looking at for this project that I'm going to talk about here in a moment is vehicle miles traveled, VMT. This certainly is a valuable performance metric, and I know California, I'm really not informed enough to speak about California, but I know California has transitioned to it either in addition to or instead of LOS as kind of, I think, city by city. So thus far, I've presented a lot of challenges, and I'm going to begin to tie them together. I believe that many of these challenges that I've highlighted can be mitigated in part or in full by maintaining large-scale citywide or neighborhood-wide models. Specifically, PTV Bistro is what we use. So my team has worked on the development of multiple large-scale PTV Bistro models. These models include dozens of intersections and dozens of approved or potential background developments. The distributions are established after verifying multiple data sources, and once established, those can be used to help determine the distributions for future traffic impact analyses. So the first model that my team developed was for the city of Nashville. Unfortunately, that model is no longer up to date. While that model was current, there were 80 or more background developments included in it, each with their own, dozens of paths. And we used those background developments to establish realistic background growth within Nashville, and we could use the distribution that was shown and determined for those developments to look at future developments. Also, in Nashville's constrained street network, sometimes the results, because we had everything put in, were really scary, but they were realistic, and they encourage the city to focus on creating mode shift instead of just trying to pave our way out of a problem. And they also, knowing that we can't pave our way out of many of these congestion issues, it also provided a data set that could be shared with the state and the DOT to push for larger infrastructure improvements that the city didn't necessarily have control over. Because as we all know, the bottlenecks on city streets really can't be resolved if we, as you leave the network and downstream, there aren't improvements at all. So also the comprehensive network allows us to make informed decisions on our mitigation measures that might be outside of the typical bounds of a study area for an impact study. So this leads to better recommendations and generalized network improvements. Okay, let me talk now about what we are in the process of doing today. So we're currently in the process of developing, it's mostly developed, a similar model for the city of Franklin, Tennessee, that's approximately 30 minutes south of Nashville. The model encompasses an area with a mix of land uses, including high density office and medium density retail and residential units. The PTV Bistro model includes more than 60 intersections and is split on either side of Interstate 65. That is represented by either the yellow line running north-south, or in the graphic, you can kind of see it on the right, 65 labeled there. So we have more than four. No, we have four, I can count. We have four interchanges with 65 in the study area. The southern boundary is Murfreesboro Road, which is State Route 96, and the northern boundary is Moore's Lane, which is actually, parts of it are just over the border into Brentwood, Tennessee. So once completed, the pre-populated development areas, distributions, and land uses, I'm preaching to the choir here, but will be easy to toggle and adjust for changes in the community. For one example is, and what we're planning here, if the impacts of COVID-19 lead to have one of the 20 background developments, say, adjust their program from hotel to multifamily. We're seeing a lot of that in Nashville right now. I love the fact that in PTV Bistro, we can just go into the trip generation and change what the trip generation is, double check our paths, but they're already in there, and toggle the quick change in the trip generation and get our results basically right away. Okay, so when the city of Franklin came out with their RFQ for this project, they didn't ask for Bistro, and we kind of went out on a limb and made the recommendation. And I'm going to explain kind of why, how we got there. So like I said, we had done this model for the city of Nashville a number of years ago. I think that model began development in 2015 or 2016. And that model really allowed us to become familiar with PTV Bistro and get comfortable with it and really learn when we want to use it. And when we want to use it is when I maybe have an impact study that I expect the land use might change multiple times, or the developer's a little squirrely and they're bouncing around with the number of hotel units they're putting in or multifamily units. If I can do that impact study in Bistro instead of in Synchro, I can toggle those changes so quickly it saves hours and hours of time when somebody changes their mind like that. So we took that model that we had gotten used to using for impact studies and we pitched it to the city of Franklin. And how we pitched it and how I think it was successful is we said, the results are quantifiable and relatable. There's great compatibility, and I especially really like the new merging features that have been introduced here recently. And then we really like the flexibility. So we like the multiple scenarios in one file, the easy updating and the trip generation built into the model, as I kind of explained, internal program QC, love the use of the zones, gates, and paths. I think it makes it so much easier. And the scenario testing as we look towards mitigation measures. So we won the project and we jumped into getting underway. For data collection, we collected turning movement counts AM, midday, and PM back in January and February of last year, luckily all pre-COVID. We also looked at T-dot ADTs, and I think we also collected some of our own tube counts just to validate. We collected thousands of photos of each intersection, drove the corridors during the peak hours, and took notes on queues, cycle failures, anything of that nature, just for model validation. And then the photos you're looking at too are drone video capture, stills from drone video capture that we used also mostly for model validation, and we felt that it would be good if we had to, say, present before council on this to kind of tell the story. Some fast facts on our model. This is our model here to the right, or screen grab of it, I should say. We have 29 zones. We also have what I call ghost zones, about 70. And the purpose of those ghost zones is we wanted to have our zones and our gates numbered in a specific way. And we wanted to have zones kind of pre-prepared for the city, because eventually we'll hand this model over to the city. And so we wanted those zones to be able to just be dragged and moved as potential new developments come online. We have 14 gates. That number may seem low to you. Part of the reason we don't have internal gates, all of our gates are external, and part of the reason for that is, first off, the 20 background developments that we have each took their own internal capture, took their own alternative mode reduction, and while there is some internal capture between developments, we definitely didn't want to overcount that. We wanted to be conservative. In addition, because we have I-65 that runs north-south through the study area, it's kind of an internal gate in and of itself. We can lose trips in the middle of the model because they hop on the interstate and are out of the study area. In total, we have over 2,000 paths, 2,466, and it took a while to populate all those paths. I don't know how long exactly. It probably took almost a month, I guess, to populate all those paths. So we first established a background or an existing model. We put on background growths, just raw background growth using historic TMC data, T-dot tube data, AADT data, and then we use street light. And the reason I wanted to highlight this is because you see here we have all these growth regions, and we identified these regions specifically. They allowed us to use street light to figure out background growth. They allowed us to, we also use street light to help us figure out distribution. And then in one of our future scenarios or two, we have maximized development potential, and we use these same regions for that as well. So that's why I'm showing this. I'm just going to skim through for distribution. As I said, we use street light. And if we're looking at this region C here, I think it's important to note that we didn't just take it, the streetlight information at face value. If, for example, in region C, we were close to that interchange to the south, we might shift our percentage for a specific background development. If we were further to the north, we'd shift the distribution in that direction. Okay, so let's talk about the scenarios that we studied here. Each of the scenarios looked forward to 2030. And each of them had generalized background growth and then programmed and recommended improvements from the 20 approved developments that we included, as they're not really background for this study because they are at the heart of the study. The approved developments we looked at in two ways. One at 50% build out, so assuming that they got more entitlements than they're actually going to build, things of that nature. If we hit 50% build out, what's that going to look like? And if it hits 100% build out, what's that going to look like? For the 100% build out, our PM peak hour generates about 16,000 trips, a little over 16,000 trips. The maximized development potential was looked at as well. And the important thing to note is originally we had 50% and 100% as the maximized development potential. And you'll see on my next slide here, as I discuss, basically we had to back it down to 25% and 50% because we just straight up broke the model. We added too many trips, and we were seeing delays on many intersections over 10,000 seconds. It was a volume that was impossible to handle, and it was another thing that we'd never be able to pave our way out of. So that piece of it told us that we needed to pivot some of our mitigation for this into policy strategies, not just infrastructure strategies. So this maximized development potential could really have its own presentation, but just to kind of be short here, we identified parcels that were primed to be developed based on the building value versus the land value. And then we determined parcels that were ripe for redevelopment based on that. We also identified infill locations based on the percentage of the building size versus the parcel size. And we took out things like car lots and things of that nature, anything with a really steep grade that would be problematic to develop on. From there, we determined how many acres are available for redevelopment. It was 695 acres, and they're split into the regions shown on the screen here. And then within each region, we looked at the zoning and land use policies to determine a kind of generalized maximum development potential by acre. So just to give you the numbers of where we are, if we were at the 100% maximum development potential, it would be 162,000 PM peak hour trips, or for midday, over 200,000 midday trips, which obviously is pretty insane. And I think you can all see why we broke the model. Okay, so right now we are in the process of determining mitigation measures. We do have them largely pulled together, but they're not finalized yet. Where we saw issues is up and down the north-south arterial on the east side. It's called Carruthers Parkway. That's really the biggest problem area for us. What we've been looking at in terms of improvements is some interchange modifications. Certainly, we have looked at some alternative intersection designs. There's one existing roundabout, and there is one future proposed roundabout that we are looking, really both of those we kind of showed broke as well. And a great example and something we did with that is that we compared the Bistro results to Sidra results, just to kind of truth test the Bistro. And one real positive thing is we found that the results generally came back the same, which is not always the case for competitors. So that really made us feel confident about the outputs for roundabouts in Bistro. I could talk for quite a while probably about the mitigation measures. I'll leave it at that and just jump to questions if we have any.
All right, thank you, Beth, very much. Sorry, it took me a second to transition back. Excellent presentation. Really interesting to see just the scope and size and just the growth and all the things and what you're doing with the modeling and how you're bringing in new tools. Boy, it puts my TIAs I did in the late 90s to shame, right? Just with how things are done now and what's available to us in our industry. So I did stuff more recently than that, but that's a good contrast point. So a couple questions for you. Actually, we have a number of them. Early on, you mentioned about some of the new trends that need consideration in impact analysis and also new tools. You did present some of that during the presentation, but can you elaborate a little bit maybe on those?
Yes, I tried to skim down that portion of my presentation.
Sure.
So really the trends that we're seeing mostly are these very unique land uses and trying to figure out trip generation for them. We have in Nashville, I've done a study for like a plastic surgery center with a luxury hotel attached. Point being, you go get your plastic surgery and then you go stay at that luxury hotel. You're not leaving, and trying to validate that trip generation. And my message for that is truly that ask 1,000 questions of the developer and document. And then when you come up with your assumptions, whatever municipality or reviewing agency you have can see some of that data or see some of that information. A lot of times developers have their own sets of information. In terms of grocery delivery and just more daily service delivery things, I'm getting packages delivered at my house every day right now. We're probably ordering food for delivery a little less often than some others, but depending, if you're in an urban environment, more of like condo, multifamily settings, people are getting food delivered frequently, and you need spaces designed to account for that, and you need to shift trips so they move to those locations. Sometimes the way we do it is we actually put everybody to the parking center, but then we also model a separate like valet loop. So we have a path that loops around for valet. I could go on more specifically, but.
Well, I'll ask another question, and then we can expand to your heart's content within the 4 minutes we have left. So, but that's a really good point in terms of having that flexibility. I mean, I guess that would be one question. You mentioned about the path creation. Given the time I have, I'm not going to read exactly. There's a few questions about that, but I'm going to paraphrase a little bit. I think there was probably a little bit of panic or cause for concern by the audience about the amount of time you said that you spent building paths, but maybe what you can address to that, and we can always go into a little bit further, but like obviously you found some value in that and some usage, like how it will benefit you in the long run. What type of experiences do you have? Maybe you could talk about that, or just about how the flexibility, was it the flexibility or the control that you have, knowing exactly which driveways are being used, or like you're saying, these kind of round the block things from the parking lot to the development, and
yeah,
maybe just elaborate a little bit on that.
Yeah, absolutely. And hey, so Megan on my team is watching this. Megan, shoot me an IM if you disagree with how long it took you to make those paths. So when we're doing an impact study specifically, I do think that it takes longer, a little bit longer, and Megan is getting super proficient at Bistro, so maybe we're catching up. But historically, it takes us a little longer to set up on the front end for a Bistro impact study versus Synchro. However, anytime it's like a multi-block study, like a multi-block development, or like I said, a squirrely developer that I don't know if I trust that the numbers they're going to give me are going to remain. Yes, setting up paths does take some extra time, and that's not a step that you have to do in just like base Synchro. However, every time it changes in base Synchro, you end up going through and reworking all your numbers, and it's a huge pain. So when you know in advance and you can set up the paths in advance in Bistro, it just is a huge time saver. We have quite a few multi-block developments, and for those, always we just start in Bistro. It makes sense. And let me see if I'm on Do Not Disturb. She didn't send me an amount of time, so.
No problem. So I think that's great, and there's some comments in here. Whatever questions we don't get to, we really do need to stick to our time frame again. But Beth, excellent. Maybe just quickly on a different topic. Early on, you had mentioned some of the flexibility or the concern about standard saturation flow rate, or use or not. And I know Eugene mentioned it about that as a theme from how VTA sets their own. Can you just elaborate on, have you used any of the user ability to adjust, different user parameters for things like saturation flow rate or things like that when you've done your studies?
So we haven't specifically for saturation flow rate, because we haven't, I can tell you in downtown Nashville, the saturation flow rate is not 1900, but we don't have that data collected necessarily for every study. I've actually proposed to the city of Nashville that you could do the analysis for saturation flow rate neighborhood by neighborhood or part of town by part of town and make that adjustment. And if they just did that data collection and came up with that number, then they could tell somebody doing an impact study, use this saturation flow rate and make the adjustment.
Yeah, that's a really good point. And I'll just close on saying that's exactly what VTA does. They dictate based on field studies, and it just highlights that you can do it either way. There's not necessarily a right or a wrong, but it does highlight the flexibility that we have in our tool to be able to accept those kind of modifications based on field data. So Beth, I'll say thank you very much. We really enjoyed the presentation. Hope you can stick around for more of the user group meeting, and We'll transition now to the next speaker. Thanks again, Beth. Appreciate it.
Of course, you're welcome.